Hello students, welcome back. So this is our lecture number 3 of the chapter Carbon and its Compound. So those who have not yet downloaded our app Nakhyatra, you can download it from the link given in the description box. There you can do the live classes, watch the recorded classes, and even online tests are also available. Moreover, you can also interact with me directly to clear all your doubts. Well, so let's begin. Here first we will study about the saturated hydrocarbons, that is alkane, and the general formula is CnH2n plus 2. Okay, let's see. First alkane. So alkane, the suffix ane means it has single bond. So the carbon atoms are linked by single bond. And it has the general formula CnH2n plus 2. Now see what happens if we put the value for n equal to 1 in the formula. We will get CH4. So it is the molecular formula for methane. Now there is a small reminder: to draw the structures of carbon compounds, always draw the carbon atoms first. So see here we have written the carbon atom first. So this is the structure for methane. Alright students, next we will see the electron cross-dot structure for methane. See here, the dot represents the electron of hydrogen and the cross represents the electrons of carbon. Now see in the right side of the slide, you can see that the carbon shares total 4 electrons, one with each hydrogen, and all the 4 hydrogens share their 1 electron each with carbon. Okay. Next we will see by putting the value n equal to 2 in the formula, we will get C2H6. Here the carbon atoms will be connected by a single bond. Okay, now we know that out of 4 valence electrons, carbon has shared 1 electron. So the remaining 3 electrons will be shared with 3 hydrogen atoms. Okay, so same for the other carbon atom also. And the compound will be ethane. Now see the electron cross-dot structure for ethane. It is just like similar to methane only. Here the dot represents the electrons of hydrogen and the cross represents the electrons of carbon. Is that clear? Okay. In the next slide, we will see by putting the value for n equal to 3. So in the formula, we will get C3H8. So let's see what will be the compound. So here we will get, since there are 3 carbon atoms, so it will be propane. Okay. Now see the electron cross-dot structure for propane. These are very similar only, the electron cross-dot structure, similar to methane and ethane. Again the dot represents the electrons of hydrogen and the cross represents the electron of carbon. Clear everyone? Now see, by putting the value for n equal to 4 in the formula, we will get C4H10. So see, there are 4 carbon atoms. That means something it will start by the root word will be but. So it will be butane. Now let's see the electron cross-dot structure for butane. It is also similar. The cross represents the electrons for carbon and the dot represents the electrons of hydrogen. Okay, this is very easy. Next we will study about the unsaturated hydrocarbons, that is alkene, and the general formula is CnH2n. Okay, let's see. Alkene. So ENE, the suffix ENE means that it has double bond. So the carbon atoms are linked by double bonds. The Zenel formula is CnH2n. Now put n equal to 1, 2, 3 like that. Is it possible? Okay, let's see. Okay, we cannot substitute n equal to 1 for alkenes, as alkenes contain double bond. See the reason? Double bond can exist only between carbon atoms, and hence minimum 2 carbon atoms are needed for the same. Is that clear? The reason is given here very clearly. Since the double bond can exist only between carbon atoms, and hence minimum 2 carbon atoms are needed for the same. So methane does not exist in nature. Methane does not exist in nature. Okay, now see, by putting n equal to 2 in the formula, we will get C2H4. First draw the 2 carbon atoms. Now see, since the compound is an alkene, there is a double bond. Now out of 4 valence electrons of carbon, 2 electrons are shared. So the remaining 2 electrons are shared with 2 hydrogen atom each. Okay. So the compound will be your ethene. Now see the electron cross-dot structure for ethene. It is also same only like alkane. Here the dot represents the electron of hydrogen and the cross represents the electrons of carbon. Okay, now see alkene, where by putting the value for n equal to 3 in the formula, we will get C3H6. So first write the carbon atoms. Since there exists only one double bond between any two of the 2 carbons. Okay. So here there will be one single bond. Now attach the hydrogen atoms to carbon atoms only after checking the valency of carbon. Keep this in mind. So we will put the hydrogen atoms. Okay, now the compound is propene. The electron cross-dot structure of propene is also similar to the previous ones, where the dot represents the electrons of hydrogen and the cross represents the electrons of carbon. Now put n equal to 4 in the formula, we will get C4H8. Okay, now this structure we will get butene. So the compound name is butene. This is the structure for butene. See the electron cross-dot structure for butene. These are very similar, the electron cross-dot structures, where we will represent the dot for the electrons of hydrogen and the cross represents the electron of carbon. Clear, everyone? Okay, now let's check the unsaturated hydrocarbons, that is alkyne, and the Zenel formula is CnH2n minus 2. So for alkyne, the suffix YNE means that it has triple bonds. So carbon atoms are linked by triple bonds, and it has the Zenel formula CnH2n minus 2. Like alkenes, we cannot substitute n equal to 1 for alkynes, as they contain triple bond. Now for a triple bond to exist, 2 carbon atoms are needed. Hence substitution starts with n equal to 2. The reason is given here clearly. So first methane does not exist in nature. So we will first put the value for n equal to 2 in the formula, and we will get C2H2. Draw the structure now. Now since the compound is an alkyne, we draw the triple bond. After sharing 3 valence electrons, each carbon shares 1 electron with one hydrogen atom. Okay, so this is the structure and the compound is ethyne. Okay, since triple bond is there, so the suffix will be YNE, ethyne. Now check the electron crosstalk structure for ethyne. Here also same, the dot represents the electrons of hydrogen and the cross represents the electrons of carbon. Next we will see by putting the value for n equal to 3 in the formula. So we will get C3H4. Now try to draw the structure. Only triple bond can come between any of the two carbon atoms. We put it in here. So we will put the triple bonds between these two carbon atoms. And here there will be a single bond. Nothing is attached to this carbon as all 4 valence electrons are shared already. So the hydrogen atoms will be attached in this carbon. So this is the structure, and now let's see what is the name of the compound. It is propyne, Propyne, propyne. Alright, now let's check the electron crosstalk structure for propyne. Here also same, where the dot represents the electrons of hydrogen and the cross represents the electrons for carbon. There is a slight mistake here. This X should not be here, it should be dot, because here dot represents the electrons for hydrogen. Alright, now let's see, by putting the value for n equal to 4 in the formula, we will get C4H6. Try to make the structure. Okay, so this is the structure and the compound will be butane. Now see the electron crosstalk structure for butane. It is same, where the dot represents the electrons of hydrogen and the cross represents the electrons of carbon. So clear everyone?